Welcome back, everyone. We're diving into some really cool AI research today.
Oh yeah, this is fascinating stuff.
It's all about how AI is starting to understand video, not just as like pictures, but as like a whole story unfolding in time.
Right, like how we experience a movie, not just a slideshow.
Exactly. And the paper we're looking at is called, get this, VideoRoPE. What makes for good video rotary position embedding?
Bit of a mouthful.
Haha, it is. But the concept itself is pretty mind-blowing, especially when you think about video LLMs.
Video large language models, right? These things are like the next evolution of AI.
Totally. They're designed to actually watch a video and understand what's going on, kind of like we do.
And that's where this video rope thing comes in, right? It's like a key ingredient for making that happen.
Okay, so break it down for me. What exactly is rope? Does it like give the AI a clock or something? How does it keep track of time?
So it's less about giving the AI a clock and more about giving each frame in the video a sort of special code. Yeah, it's like imagine reading a sentence, right? Each word has its place in the sentence. Rope does something similar for video frames. It tells the AI where each frame fits into the whole sequence.
Okay, so instead of just seeing a jumble of images, the AI is starting to see like a narrative, a flow of events.
Precisely. It helps the AI learn the order of events, how the story unfolds.
That makes sense. But I'm guessing videos are way more complex than just sentences, right? I mean, there's so much going on visually.
Oh, absolutely. Videos aren't just linear like text. You have the height and width of each frame, objects moving around within the frame, and even the camera itself could be moving, panning, zooming.
Right? It's a whole different ballgame.
Exactly. And that's one of the big challenges that VideoRoPE is trying to address. You see, if you just flatten a video into a one-dimensional sequence, you lose all those crucial spatial relationships.
I see. So it's like trying to understand a movie by looking at a pile of unsorted photographs. You might recognize faces and objects, but you'd miss the whole plot.
That's a great way to put it. You lose the context, the connections between things, and that's where VideoRoPE comes in. It tries to model the video as a 3D space, considering both the temporal dimension, which is time, and the spatial dimensions, which are height and width together.
Okay, so instead of just seeing a bunch of separate pictures, it's like teaching the AI to see the video as one continuous evolving scene.
Exactly. It's about understanding the video as a whole, not just a series of disconnected images.
That makes a lot of sense. But I'm curious, have there been other attempts to tackle this before? I mean, this can't be a brand new problem, right?
Oh, there have been. Like, you have things like TAD-ROPE and MROPE.
TAD-ROPE and MROPE, catchy names.
Yeah. But even though they've made some progress, they have limitations.
Like what?
Well, one of the big issues is that they can be easily distracted.
Distracted. Like how?
Think about trying to follow a conversation in a noisy room. It's hard to focus, right? Well, some AI models have the same problem when it comes to video. If there are similar but irrelevant frames in the video, they struggle to stay focused on what's important.
Oh, I see. So it's like the AI is watching a movie with a bunch of random scenes thrown in is just to confuse it.
Yes, and those are what researchers call distractors.
Distractors. Clever. So how do they even test how well an AI can handle these distractions? Do they just throw a bunch of random clips at it and see what happens?
Well, there's actually a specific test they use called, and I'm not kidding, V-NIAH-D.
V-NIAH-D. What on earth is that?
It stands for Visual Needle in a Haystack with Distractors.
Visual needle in a haystack with distractors. Okay, that's quite a name.
It is, right, but it really captures the essence of the challenge.
So what kind of challenges does this V-NIAH-D thing throw at the AI?
Oh, all sorts of tricky scenarios. Imagine they might show the AI a video of a wedding, right?
Okay, a wedding, yeah.
And they ask a simple question like, what color is the balloon on the groom's head?
Seems straightforward enough.
Right, but then they add a whole bunch of other scenes with balloons, but these are from birthday parties, parades, you name it, just to see if the AI can stay laser focused on the relevant moment in the wedding video.
Ah, that's devious. So if these older models, like the TAD-ROPE and MROPE, struggle with those distractors, how does VideoRoPE avoid getting fooled? What makes it so special?
Well, that's where those 4 key properties we mentioned come in. They're what really sets VideoRoPE apart and helps it stay on track.
Okay, I'm all ears. Lay those properties on me. What makes VideoRoPE the superhero of video understanding?
All right, well, first you've got the 3D structure, which we've already talked about a bit. That's like the foundation of VideoRoPE, allowing it to see the video as a continuous, dynamic scene. But on top of that, we have something called frequency allocation.
Frequency allocation sounds a bit technical.
It is a bit, but basically it means assigning different frequencies to the temporal and spatial dimensions.
Okay, so time and space get different frequencies. Why is that important?
Well, think about it like this. It helps the AI prioritize the timeline correctly. You don't want it getting so bogged down in the visual details that it loses track of when things are happening.
Ah, so it's like teaching the AI to pay attention to the rhythm of the video, like not just seeing where things are, but how they're moving and changing over time.
Exactly. And then you have spatial symmetry.
Spatial symmetry, right? What was that about again?
Spatial symmetry makes sure there's a balanced relationship between the visual information and any text that might go along with it. So imagine the AI is given a text description and then shown a video. Spatial symmetry helps it give equal weight to both of those things.
Okay, so it's like making sure the AI doesn't judge a book by its cover or, well, a video by its visuals alone. It considers everything.
Precisely. And finally, there's temporal index scaling. This one's a bit tricky, but it basically gives the AI flexibility in how it spaces out events over time.
So why is that important?
Well, different videos have different paces, right? A slow burning drama unfolds a lot differently than a fast-paced action movie. Temporal index scaling lets VideoRope adjust to the timing of events in each type of video.
Ah, I see. So it's like getting the AI a customizable speed control. It can fast forward or rewind through the video depending on what's going on.
You got it. And that adaptability is really crucial for truly understanding video as a whole.
Wow, it really sounds like VideoRope takes a holistic approach, considering all these different aspects of video to figure out how events unfold over time. Pretty impressive stuff. But how does this all translate into real-world performance? Does VideoRope actually live up to the hype?
It does. The results are pretty impressive, actually. We see significant improvements over those previous methods, like across the board, different tasks.
Oh, really? Like, what kind of tasks?
Well, for one, long video retrieval, that's like finding specific moments within, say, hours of footage. VideoRope is really good at that.
Makes sense. So it's not getting lost in the haystack of video frame.
Exactly. And then there's video understanding, like answering questions about the content of a video accurately.
Oh, wow. So it's not just recognizing what's happening, but it can actually, like, process and understand the events?
Right. It's moving beyond just perception to actual comprehension.
And what about those, what were they called, those V-NIAH-D challenges?
Oh, yeah, the distractor gauntlets.
Does VideoRope ace those too?
Absolutely. Doesn't get fooled easily, but here's where things get even more interesting.
Oh, lay it on me.
VideoRope has shown some real promise in video hallucination.
Hold on. Video hallucination, what in the world is that? Is that like AI making up its own movies?
Sort of. Think of it as generating video sequences from, say, textual descriptions or prompts.
So you give the AI a script, and it tries to create a video that matches it.
Yeah, that's the basic idea. Like AI is directing its own little movie.
That is wild. So VideoRope is not just understanding video, it might actually help us create it. I mean, what are the implications of that?
The possibilities are, well, pretty vast. Imagine creating realistic video content without even needing cameras or actors.
Whoa.
Or think about virtual reality experiences. You could have these immersive worlds generated on the fly based on, well, your imagination.
That sounds like something straight out of science fiction. But, okay, before we get too carried away with the future, let's come back to those 4 key properties for a sec. You know, the ones that make VideoRope so powerful.
Right, right. Those are really the foundation.
Okay, so the 3D structure, we kind of get that. It lets VideoRope see the video as a whole, not just separate frames. But what about that frequency allocation thing? You said it's about giving time and space different frequencies. Can you break that down a little more for me? Like, what does that actually mean in practice?
Okay, imagine you're watching a video of a basketball game, right?
Okay, basketball. Got it.
Lots of stuff happening on screen, players running, the ball being passed, the crowd cheering.
Right, lots of action.
So frequency allocation makes sure that VideoRope doesn't just focus on where those things are in each frame, but also how they change over time.
So, like, it's not just about seeing where the players are, but also how they're moving and interacting with each other.
Precisely. It's giving the AI a sense of the flow, the rhythm of the game, not just a static snapshot.
Oh, that makes sense. So it's processing those changes over time, not just the individual positions.
Exactly. And then we have spatial symmetry, which is all about making sure there's a balanced relationship between the visuals and any text that might come with the video.
So it's like if you're searching for a video of, say, a cat chasing a laser pointer, you want the AI to understand both the visual part, a cat moving quickly, and the text description chasing a laser pointer to find the right results.
That's a great example. Spatial symmetry ensures that both the visuals and the text are given equal weight in the AI's understanding.
Okay, that makes sense. It's about considering all the available information, not just favoring one type over the other. And finally, we have temporal index scaling. That was the one about handling different video paces, right?
Exactly. So imagine you have 2 videos. One is a nature documentary with these long, slow, sweeping shots of landscapes, and the other is a crazy car chase scene, super fast cuts, and quick movements.
Okay, very different vibes.
Right, so temporal index scaling allows VideoRope to adapt to these different paces. It can understand that events in the documentary are unfolding over much longer periods, while in the car chase, things are happening super fast.
So it's like the AI has a speed control, right? It can slow down for the nature doc and speed up for the action flick.
You got it. It's all about flexibility, being able to adjust to the specific rhythm of each video.
This is incredible. It really feels like we're unlocking some fundamental secrets of how AI is learning to see the world, like how it's developing a sense of time and space, just like we have. It's mind-blowing.
It is amazing how far this technology has come.
But I can't help but wonder, what does this mean for the future of video technology? I mean, are we on the verge of a revolution?
Well, it certainly feels that way. The potential impact on industries like entertainment, education, security, even healthcare, it's massive.
Whoa, okay, I'm ready for the revolution. Let's start with entertainment. You mentioned video hallucination earlier. Could we actually see AI-generated movies and TV shows?
It's definitely within the realm of possibility. Imagine giving an AI a script, maybe even just a story idea, and it spits out a full-fledged video.
I mean, that would change the whole game for filmmakers.
It would be a huge shift. Of course, we're not quite there yet. There are still a lot of creative and technical challenges to overcome.
Sure, sure, but the potential is mind-boggling. What about education? How could VideoRoPEs and these video LLMs change the way we learn?
Imagine interactive video tutorials that adapt to each student's learning pace and style. Or what about virtual field trips where students can experience historical events or explore different parts of the world?
Wow, that would make learning so much more engaging.
Exactly. It's all about creating these rich, immersive learning experiences tailored to each individual.
Okay, what about security? I can see some pretty big applications there.
Absolutely. Think about security cameras that can analyze footage in real time, spotting suspicious activity and alerting authorities immediately.
Wow, that would be a game changer for law enforcement.
It would. Or imagine AI systems that can sift through hours of surveillance footage to find specific individuals or events much faster and more efficiently than humans.
Okay, that's pretty impressive. And what about healthcare? Any potential there?
Tons. Imagine AI-powered systems that can analyze medical imaging videos, like ultrasounds or MRIs, to help doctors detect abnormalities or make diagnoses.
Oh, wow. So it could actually help save lives.
Potentially, yes. Or think about surgical robots that can learn from videos of expert surgeons, improving their precision and efficiency during procedures.
It's incredible how much potential this technology has. But, with all this talk about the amazing things VideoRoPE can do, it's also worth considering, like, are there any limitations? Anything it still struggles with?
Oh, definitely. I mean, even though VideoRoPE is a big step forward, it's still early days. There's a lot of research still happening to, make it more efficient, more scalable.
So it's like we have the basic recipe for an amazing cake, but now we're tweaking it, trying to make it even better.
Yeah, exactly. Researchers are constantly experimenting, trying different architectures, different parameters, different training data sets. It's all about making VideoRoPE as good as it can be.
And I imagine, like, the complexity of video itself is a constant challenge, right? I mean, we've talked about all those dimensions, the movement, the camera angles. It's a lot of data for the AI to handle.
It's a huge amount of data, and as video resolutions get higher and frame rates increase, the computational demands just explode.
Yeah, it's got to be a ton of processing power. So are researchers working on ways to make VideoRoPE more efficient? Like, so it doesn't need a supercomputer to run?
Oh, absolutely. That's a big focus. I mean, the goal is to make this technology accessible to everyone, not just those with, massive computing resources.
So someday we might be able to run VideoRoPE on our phones.
That's the dream. Imagine, like, being able to create and edit videos on your phone using AI-powered tools that understand the content as well as you do.
That would be incredible. It really feels like this technology has the potential to democratize video creation, Put those powerful tools in the hands of everyday people.
I completely agree. It's an exciting time to be working in this field.
Well, this has been an absolute fascinating deep dive. I feel like we've only just scratched the surface of what's possible with VideoRoPE and video LLMs.
Oh yeah, we've only just begun to explore the possibilities.
It's amazing to think about how these advancements are changing the way we interact with video and how AI is starting to understand the world in ways that were, well, unimaginable just a few years ago.
It's a paradigm shift, for sure, and it's happening at an incredible pace.
Well said. And to all our listeners out there, we hope this deep dive has given you a glimpse into the exciting world of AI and video. Who knows, maybe you'll be the ones to create the next groundbreaking application using this technology. Keep exploring, keep asking questions, and as always, happy deep diving.